In AI chip, the current limitation is not heat generation. It is basically that heat cannot go anywhere, cannot dissipate fast enough.
GPUs were good for the fast processing that we use for our laptops. But when it comes to AI, we need to be thinking more innovatively.
One of the reason why silicon is so popular or so widely used is because silicon is a single atom, right? I think the diamond would be similar kind of material. Space is the new frontier. Your satellite internet is coming from space. There are defense application manufacturing in the space, or going to moon for energy security, helium free, making moon as a base for launching to Mars. My advice would be just do material science, but do at the intersection of other things. Learn coding, do with AI and material science, because everything is interdisciplinary, cross-disciplinary.
Earlier we used to be thinking that like the innovation is something that Chinese companies lack. Now, I think we will be mimicking Chinese innovation when it comes to long mileage electrical vehicles and also making them cheap and light.
That is where I think testing becomes very important.
What's happening, folks? Thanks a lot for tuning in to the Altered Perception Show. My hope is that before the show and after the show, your perception has been altered. And to do that, today we have a special guest, Dr. Pradyumna Gupta. So Dr. Pradyumna Gupta has a PhD in material science, and he definitely has a lot of experience in the field. And not only that, he is considered as the Uber of material testing. He has founded a company called Infinita Lab, which we're going to cover about, but he's also the chief scientist there. Without further ado, let me introduce Pradyumna. Thanks a lot for joining the show.
Thanks, Gaurav. Thanks for inviting me.
Yeah, I'm super excited for this one. We've been talking offline on the potential of material science and how we still have to have that chat GPT moment for all the materials that we're going to be talking about related to semiconductors and how the chips and everything can be enhanced with the help of it. This is going to be a fun experience for me. I've never dealt with material science, so I'm going to be learning a lot from you. Without further ado, let's start with your introduction, Pradyumna.
So thanks, Gaurav. Introduction wise, you said a few things about me already. So I'm a PhD in material science, and not only PhD, but I love material science. That's why I'm here. But I describe myself as an entrepreneur that has material science background. And in today's world where AI hardware is kind of a big thing, AI is a big thing, I think, that matters a lot. Material science matters a lot. So, and that is my passion. I work at the intersection of AI, semiconductors, and materials.
So let's talk about it. Why do you say that the material science is definitely plays a big role in terms of AI and semiconductors?
I think sometime back, maybe a few months back, NVIDIA's Jensen Huang, he said something along the lines of that this is one of the biggest disruption. AI is one of the biggest disruptions since 1960s in computing. And I totally believe that it is like a whole new world in computing that has opened up. Those viewers who have gone through 1995, when the personal computers came, that was a big change. Suddenly companies like Google or Amazon, those use cases really became a reality. This revolution, because people had personal computer, they could do things on sitting on the desk, connecting with the world. There were use cases. Now, similar kind of hope has come up with the AI. And why I say that material science is important there, because AI is nothing if it is not material science. There are reason why the compute is kind of at the stage it is right now, and it is not kind of it has not kind of scaled is because of material science. The materials that are supporting the AI are not at the level that AI can kind of scale. So that's a limiting factor right now. So that's why I'm saying that material science is very important at the moment.
No, I think that makes total sense, Pradyumna. And so my next question to you is, I think you have described Infinity Lab as the Uber of the material testing. So could you unpack what that means and what accessibility in material testing is so important right now?
So, I mean, that's a great question. And there is a reason why I described Infinita Lab as the Uber of material testing. Currently, there is a lot of R&D that is required for innovation. And currently, it is more important because of the AI hardware. A lot of technologies that were off the shelf, some university research, those are being pulled in to create the next generation of materials that can support AI. It is like we were here up to now. There used to be an incremental improvement, and that was sufficient. Last 20, 30 years in materials. But AI has required that we were here, and incremental is no longer sufficient. So if we are here, then it requires like almost off the chart improvement. So that requires that a lot of technologies that are on the shelf are being pulled. At the same time, semiconductor companies are finding it very difficult to fund the R&D. So while it is a lot of innovation is required, the funding is not there. There need to be better testing to support, or better, more productive, low-cost testing that can support this leap in the material innovation, right? If you take a typical company like Applied Materials or Lam Research or Intel, all these companies that are doing semiconductor research, you would find that they are they typically have like 30% of the testing facilities in-house. The rest of it, they do it outside, no external labs. But external lab space is so fragmented. Someone does metrology, another one does ASTM. Some people do accelerated aging. Tons of different kind of techniques. I mean, we count. Then there are easily 20,000 tests we do at Infinita Lab. Different tests, variation of tests, and to deal with complexity is crazy. So that is where Infinita Lab solution is. That okay, we take care of that complexities for the company. So you do your 30% of the test, and rest of the 70% is through us and single point of contact. So we come and we have some called embedded testing advisors that we are dedicated support to support the engineers who want to do any kind of testing. Dedicated testing advisor from Infinita Lab comes and does all the testing for them. So that way, sort of, R&D is better supported. Engineers don't have to, client engineer do not have to deal with all the complexities to access the testing which supports the R&D basically. So R&D goes fast, 3 times, 4 times faster, which is required really for AI hardware, the pull that AI hardware created. And it is absolutely crucial that this kind of service, and we are getting a lot of this, we are getting a traction that almost all the cutting edge companies like Applied, Lam, Tesla, SpaceX, Intel, they are our customers.
That's awesome. And what kind of testing do you typically perform for your clients, whether it be Tesla or Meta or any other clients?
So testing is usually, it's called advanced metrology. It is microscopy or other kind of measurement like RBS, XPS, material science people would understand. It is materials property test, for example, mechanical testing, electrical testing, optical properties. So right now, photonics is coming in a big way, because part of the chip is being replaced by electronic signal, replaced by photons, because photons do not generate heat. They just pass through their light. So all these testing and new type testing, any kind of material related testing we do.
Yeah, so you must be like in the cutting edge of a lot of like new materials that could potentially help accelerate the development of AI and AI hardware.
Absolutely, absolutely. I think there is a lot of innovation going on in materials itself. Like silicon is replaced by gallium nitride and silicon carbide in many cases where there are power requirements because these are high bandwidth materials. And there is a lot of research in space application where radiation is a big issue, or advanced packaging is becoming very, very important to deal with. And there, the dealing with the heat issues is actually a very, very important aspect. So all this requires development of these kind of material require testing at various level. So we are involved with that cutting edge testing that is going on.
And are these based off of like any specific industry, or you can help clients in different industries, or do you focus more on the EV or the AI chips side of things?
I mean, it is quite broad. So anything semiconductor, batteries, EVs, aerospace application, 3D printing, and they are also related, kind of quite a bit related. Quantum materials, all these things. We do testing for. What is a running theme is that we either have a very cutting edge material development, that is where the testing is required, very high level testing is required, and then a lot of if there is a raw material qualification, or there is a supply chain or quality issues, then there is a reliability testing, a certification that comes into play. Also, in aerospace there is a lot of safety testing or environmental testing, where you are launching a product and you want to test how it does in different environments.
How many employees do you have right now in your company?
So we have about, altogether we have 4 companies. The total, we have 200 plus employees.
Okay, so you talk about that in one of your posts. I think you mentioned that AI, and forgive me if I'm butchering it, but you said that that AI won't fail on compute, it will fail on materials. So can you explain like why materials are such a critical bottleneck in scaling AI?
Yeah, currently I think AI is kind of running on very old legacy hardware. So the hardware that was not made for AI requires huge amount of bandwidth. So, and very in a very short time, right? So currently it is all legacy, and that's why there are issues like heat. It is just heating up. There are bottlenecks. That's why, even I bought a MacBook Air, and it doesn't have a fan. But I remember when I bought a MacBook Air with the M1 chip, it used to run so cool. Nothing like it will go 20 hours, very cool, nothing happens. And now I run a small AI uh, on the M4 chip, a small AI algorithm, and it just heats up like crazy. So you can think of the current chip that Apple has, which is the top most chip, M4. It cannot run very simple AI algorithm. So you can see that where it is right now. And that is the physical limit I'm talking about, that materials currently are not supporting it. There are issues like heat, energy, bandwidth, interconnects, and all that. So that is materials bottleneck. Even the material, the everything based on silicon, it is not suitable. So there are talk about, and actually it is being replaced by very high power materials like gallium nitride and silicon carbide, which is in very specialized application, very specialized chips. But now I think slowly it will come into the mainstream, and that is my thought is. So main thing is that compute growth is not infinite, and materials breakthrough are the really true unlock in performance, and that is where basically we have come to a kind of hit the wall, and there we have to kind of raise our material to in order to go up.
Absolutely. I think you have nailed it. I think I agree with you. I mean, we cannot just rely on these silica chips. And if you think about it, producing these silica chips requires so much of intense development. You have to be in a clean room setting, and you have to have like certain process which takes a lot of time, from all the way from extracting silica to actually producing them into wafers, to actually producing uh, chips from it. And that's the whole process, the lithography, the optical side of things, which takes so much of effort. So it definitely has to be some new way of developing these AI systems. And if you think about it, we didn't, like, AI happened, right? So we didn't know that we would be developing these GPUs or using these GPUs for AI. So it's like GPUs were good for like the computers and the fast processing that we use for our laptops. But when it comes to AI, we need to be thinking more innovatively and actually develop new systems to combat the AI that we are needing more and more now with these agentic systems.
You're right. I think, GPUs were developed for gaming, all right, and parallel processing basically was developed on that. So current AI uses GPU, but that is, GPU was not made for that. That's it. That's why there is a whole firmware coda that you have to write in order to use it for AI. I don't know whether it will be replaced so fast, but I think there will be more native, like TPUs are more native for for AI application. So there will be new TPUs, new custom silicon that is being developed by Amazon, for example, or Meta, that would basically very specifically for the AI application or running AI. So I am excited to see what those things would be. But there are many companies that are making custom silicon.
Yeah. Do you think that, if you think about it, like we have smartphones, we have laptops, then we have smart devices like these Apple Watches, and even now we have the augmented reality headsets. All of these have different, different configurations, different types of hardware requirements. Do you think that the materials have to be specifically developed for each of these technologies, or the AI chip, the TPU, or any custom chip we are developing is going to be sufficient?
No, I think you got it very right that everything will become very custom. The materials will be custom. I mean, to a certain level, they are. If you nowadays, the power brick. If you see the MacBook Air, the power brick, it is like this big, very small, like 30 watt. It is very light too. It used to be that you used to have a whole brick that used to power, right? The transformer which you used to convert. And thanks to material innovation like gallium nitride and silicon carbide, they basically reduce it and to a smaller size and very small size. Now it is like what you used to use for iPhones. That kind of a power brick is there for.
Yeah.
Yeah. Coming to you, what comment you made about everything will become custom. That is true.
Yeah.
So there is a kind of separation has developed between the fabs and the design, and that I think has driven this kind of very uh, custom chips with custom material for specific
Use case.
function, right? And also the volume has increased. Huge volume. I mean, TSMC companies like TSMC, Taiwan Semiconductor Manufacturing, they are the fab for the world. The most cutting edge, high cutting edge chips they basically make. And if you look at them, they are they will not take small volumes. So partially, I think it has come from the huge volume. Chip is everywhere, right? So huge volumes of the chips, very custom or niche chips.
Yeah. So now I want to talk about the space, the aerospace side of things, and I know that you also have a lot of testing that you do for companies over there. You also have said that the future of space flight won't be decided by the big engines, but by materials that don't flinch at 1600 degrees plasma. So I want to first thing first, if you can help the audience explain what does that even mean to like layman's term, and then also what breakthroughs are needed to make that possible.
Yeah, so I mean, if you think about it, I mean, if you have followed Starlink, right? So they were putting a lot of engines, small Raptor engines, and they were saying that the instead of one or two engine or three engines, they had like probably 30s or some numbers, like huge number engine, because and they were Raptor engine, and there were kind of a lot of focus was on how to even lift this huge machine, right, and send it to space, right? And
Yeah.
recently they succeeded, right? Really succeeded recently only. So I mean, obviously, the first thing is that whatever you can send, you have the enough power, enough thrust to actually lift it up and go. So obviously, there was a focus on engine, and which is fine. But then engine, basically, once the engine are good enough, um, there is still the priority would shift from saving the cargo, saving, the other materials that they are using. And if you look at the Starship, when it returned, it was all blue and yellow and red because it got a beating from the re-entry. When it got re-entry, it got really hit with the very high temperature plasma. It's huge, heavy machine. So think about it. If, even very light stuff used to get beating, and then you have tiles and everything to very high temperature tiles to actually protect it from the heat that they have to go through the atmosphere. So basically now the more focus, I'm not saying that complete focus, but more focus would be how to save this thing. And then there are many technologies. So the very high temperature plasma that actually comes, how to save it. There are many technology which provides a shield. So they will just put an electromagnetic shield at the front so that it can kind of deflect the plasma. That is one suggestion, but that requires very high voltage. And I don't think that it is practical, but you know, I have seen many things become practical. But irrespective of whether the high there is a plasma shield, it's still you would need very high temperature withstanding tiles or materials for a safety margin. What if the shield failed? Then you will not let the people die.
Yeah, totally.
Or, burn alive, right?
Yeah, that's such a great point. And I mean, if you think about it, like Starship to hypersonics, like these aerospace materials face extreme environments, right? So, with that being said, like you have that many materials going on into space and then coming back, and you also said that they come back differently. Their coloring has degraded, and the materials is also like deteriorated. So, what role does material testing play in ensuring that these systems don't fail?
I think one thing which need to be understood, if you look at the failure point, failure modes bell curve, right? So in the case of a cup, for example, the failure modes, you don't even consider the tail cases, right? You will totally ignore tail cases because it's not so critical that your cup failed, right? You will buy another cup. But in the case of aerospace, those tail cases become very important. Everything becomes any kind of failure mode becomes very important because failure is not an option. You have a single crack, conditions are so harsh that it will just lead to catastrophic failure.
Yeah.
So that is where I think, testing becomes very important. You need to know what kind of failure modes are there. You need to have a very large safety margin. And it's very real. It's a real world reliability. You have to check. So if the aeroplane that you go into, every time it lands, every time it goes up in, it is checked thoroughly and certified by people. And that's become very important. I mean, if you are in the car, you can probably, your car broke down and you are on the side of the road. Your plane broke down. You're not on the side of the road.
You are in another universe.
So, so that is like kind of that is where the testing comes in. That
Yeah,
you
yeah,
saw you saw Boeing, how many kind of accident Boeing had, right? So they I think overlook or try to cut corners on a lot of safety related procedures.
right. No, I think I'm understanding now more of why testing is needed, specifically in these cases like airplanes, aerospace engines, and just like these spaceships that we are going to be using. And if you think about it, like we are, we have not even started. We are just scratching the surface of space travel. You're going to have so many different types of space engines, spaceships that's going to be protruding out of earth, that you need to have really good materials in place so that they can go and come back without any issues, and also have a durability to it.
Yep, totally. I think space is the new frontier. Uh,
Yeah.
so, your satellite internet is coming from space. There are defense application, and then there are a lot more application in manufacturing in the space, or going to moon for energy security, helium-3, or making moon as a base for launching to Mars, right? All these things, and there will be more and more applications. So more reliable materials so that we can actually reach there, more reliable materials so that we can actually successfully colonize moon. Um, more reliable materials so that we can do what we want to do. It's become very crucial, in space application.
Yeah. I want to ask this question of coming back from space and the aerospace topic, which is very interesting. To if you had to bet on just like one material or the class of materials that will define the next decade of innovation, what would that be? It can be in the space industry, it can be in AI industry, it can be in any industries we have talked about so far.
So I'm kind of very bullish on AI. I think AI and space are two very amazing things. So when I think about AI materials, I would say I would bet on gallium nitride, silicon carbide. Um, there is diamond that is coming up, but I think diamond probably
It's too
maybe a
expensive.
decade or 2 decades away. But diamond would be amazing material. It is a single atom system, and like silicon. One of the reason why silicon is so popular or so widely used is because silicon is a single atom, right? So when you have single atom, its system is so simple that you can simulate it, you can do all sort of things, you can understand the properties. And I think the diamond would be similar kind of material. I mean, this will come the next, well, maybe a decade later or maybe later, a diamond would be that material. But currently, I would bet on gallium nitride and silicon carbide for power and AI efficiency. That is for AI. And
Yeah.
probably for AI, I would also bet on the 2D materials for future interconnect. And, I'm talking about graphene and Moly MOS2. Mm. So these are for transistors, future interconnects.
So I want to ask you, how do you come up with like that? Hey, this material will be good for the application of AI. This material will be good for the space. Like, do you have to perform like some sort of chemical testing in your labs? to order to say that, or is that like that behavior, the the AI hardware or the chip requires that certain kind of behavior, so then you kind of assess like what properties or what chemicals go well with it, and that's why you're coming up with these materials.
So, I mean, it is function, right? You want certain function or properties out of a material. So there are certain requirements. For example, your hair, right? I will give a kind of a parallel between the chip. Chip has many different, things, right? And different that has a specific function, right? If you think about gate, it is kind of moving, changing the direction of electron flow, or it is basically kind of storing electrons or releasing electrons, or you. So those are you're manipulating basically electrons, right? You're storing them, moving them this direction, that direction. You're storing. So these kind of things are happening. Similarly, so they require certain properties in order to do that, right? So that is what defines what material would you use. So for example, if you want to store electrons at certain small space, so that would define what kind of material you would have so that it can store, right?
Mm.
Or if you want to repel electrons, it goes and then it repels, right? You want so that it got turned into another direction, then you want to have certain doping in there in order to repel it, right? So that is how it is decided. So it is not that AI has one type of material. These are base material which can actually do a number of things. It has a number of different kind of material systems that are based on what kind of property you need at that specific place.
Yeah. So you said that the silica is just like a one atom chemical. So why is that the only reason why it's used so widely in the semiconductor industry, or is there any other reason of why the silica is the most used chemical?
Fundamentally it is a semiconductor, right? So you can dope it. So PN, if you understand PN kind of, so it has semiconductor. It can have metal-like behavior. It can have so semiconductor is semiconductor, right?
Yeah.
It can have a metal-like conduction, or it can stop the conduction. Both.
Mm.
So it is at the interface. That's why silicon is so famous. You can just dope with certain impurities, and it can exhibit properties that are on either side.
And what is doping?
Doping is that you just put a very small amount of a different material, different element to change the property. Doping is basically doping very small quantity of something.
I see.
Yeah.
I see. To kind of get the desired output basically from the element.
Yeah, but when I was, my comment was that silicon fundamentally is a very simple system. It is one atom. So if you have, let's say, a system or material which is consisting of many elements, right? Gadolinium, arsenide, boride, something like that, then there are a lot of interactions, right? Atomic interactions and other interactions. So when you have a single atom system, then it is simpler to study or research, and then progress is also faster. So for example, carbon is a very single system. So you have graphene, which is carbon, you have diamond, which is carbon, you have obviously coal. There are many forms of carbon. So it's very well studied system because it is just one atom.
So why aren't we using carbon instead of silicon?
So currently, diamond is a very good heat conductor, but it is a good electrical insulator. So it's high bandwidth material. So, but since it is very good heat conductor, biggest problem with the AI is that the heat generated in the chip cannot dissipate fast enough.
And can you explain that? Sorry, I don't understand.
So it is like, so in very layman terms, it is when you have a lot of traffic, right? on the road, what it will lead to, right?
Yeah.
It will lead to a lot of, jams, road traffic jams and all that, right? And you can think of it like still you push through that, then basically it is creating a lot of heat, right?
Mm.
So similar thing happens in when you have AI requires huge amount of bandwidth to and fro, right? And at a burst, almost burst in a lot of burst. So basically, what happens is that it creates a lot of heat in the system. In the current hardware level, it just burns the hardware. If you put that, my MacBook M4, the current MacBook Air, if you put it on the lap and run a AI algorithm, it will heat up. You will burn.
Really?
Yeah. So that is the problem right now.
Yeah. So you think that diamond is a good insulating material for like power, but when it comes to the actual heat, it's not that good?
No, it is very good. It is very high thermally conductive material. It's the best thermally conductive material in the world right now.
I see. So
But the
any
problem,
type of heat you provided, it's not gonna do anything to the diamond.
it will dissipate it very fast.
Oh, it will dissipate.
Yeah,
So the
because
diamond.
it is very thermally conductive, right? So it
Oh, so that's
goes away.
I see what you mean. So it can quickly just burst, and
Yeah.
that's what you need in the AI chips, right?
Yeah. In AI chip, the current limitation is not heat generation. It is basically that heat cannot go anywhere.
Hmm.
So when it stays there, it start burning the circuit, right? So it lowers the performance. Everything goes down, right? System goes down because there are fail-safe mechanisms. So as soon as they go above a certain temperature, they shut it down. So the whole stack kind of shut it down. So when diamond kind of material, heat goes away very very fast. You can extract it very very fast. But the problem with the diamond is that it is not no it is now it is being made synthetically very well, but still the quality is not high enough. It is not to a level where the impurities are gone. You need really very pure diamond. You don't
I
need
see.
any kind of defects and impurities and other things.
Yeah. So if you were to bet on a material that's going to be used like decades from now in the AI chips or any type of advanced technological systems, you think that that's going to be diamond, or was
Yeah,
there some other material?
I would say that this will be some sort of single system, single atom kind of system, and I feel the diamond could be one. I mean, decades is very hard to kind of predict, but
Yeah.
that's my wild guess, I would say.
No, totally.
Yeah.
With AI models like demanding more bandwidth and energy, so where do you see the sweet spot between computing performance and material efficiency?
So in the current model, more compute means more power, and that is the reason there are more heat. So what I would say is that when I define the performance, that I want to kind of say that okay, performance. What would be the performance per watt per gram of the material? You know, so that is where I would say the sweet spot would be. And the innovation it will lead to is better interconnect, better cooling material, and low loss substrates. Substrates should be low loss. But I also think that replacing the the part of the chip that are processing electrically, and replacing it with the photonics, where everything is running on optical signals, that would be another level of innovation. And I think that would be required, I think, in a few years. So a lot of things would be like photonics. Instead of electronics, they will be photonics.
And what do you mean by that? So you're using basically photons of light to kind of transfer information instead of electronics transmission?
I will tell you a little bit of basics on layman terms, right? So electrons, currently everything is electronic, right? So
Yeah.
electrons move. So basically what computer is, that you have electrons that are moving, and in the chips they are manipulated, right? So there are gates that are made, and or not all these gates are made, where basically electrons are moved in this direction, that direction. So many electrons, store them. This many you store them. So everything is done with electron. That's the currency you are kind of propagating through the system. Now, problem with the electrons is, and it's a problem. It's a problem, and it's a good thing both. Is that electrons are heavy, right? And they are influenced by electromagnetic field. That's why you can influence and move around, like, right? But if you replace it with a photon, photons are light. They are literally light. Photons are literally light, but they're very light too. Like, there is no mass. So that's why the heat generated is not there.
Yeah. And what about the reaction? Does photon can react with anything else?
So, I mean, that is the part of the puzzle, right? There is a whole field called photonics, just like electronics. When I did my PhD, in photonics. So the whole premise was this, that, photon, you can make all optical computers where you can move photons, do things that you do with electrons, with photons. If you think about the communication, right? I'm talking to you, it is going through optical fiber, right? It used to be copper fiber. So that replacement has happened in the past. Electronics to photonics, right? And think what it did to the world. You are able to talk to me because the signals are so fast. It is photonics, right? Without laws, it can go to, from here to UK in the fraction of the second. That is the kind of thing you would see in your computer, and that is what is required for AI.
That's awesome. And so, in these photonics, I had a guest in the past. He talked about quantum computing and how it works behind the scenes. And he said that a lot of it is these photons, which are kind of bouncing off light from one place to another to kind of produce or like excite an electron to the superposition or the position that the scientist wants. And they have a specific calculation for it. So what you're saying that quantum computing photonics that is applied over there can be applied to these AI chips as well?
Photonics is its own field, right? And depends how we're going to use it. I mean, the good example is the example I gave you. And that gives you idea about the scale of it, So it just totally changed the way the communication, I mean, the whole internet right now depends on what. I mean, there's a new type of internet that is coming up, which is basically satellite internet, right? But which maybe will be able to replace or maybe augment. But this is a very solid system of a communication right now, that you can talk to someone sitting in Japan or other part of the world, and as if that they are sitting right next to you. So that is because of the photonics, because that photons travel at the speed of light, and they can travel without loss. And the loss is very important, because wherever the energy loss happens, that converts into heat. This is why the computers are limited right now.
I see. So basically what you're saying, and correct me if I'm wrong, but what you're saying is that these whatever you want to use, whatever material you want to use for these systems, you should pick a material which has the least amount of heat generation, and it can go from one medium to another medium super fast. That way you can maximize the efficiency of these intelligent systems, or even the aerospace. You can just like
Absolutely.
have a system.
Absolutely. That has happened in the communication when you're sending signal, very simple things, where you're sending signal from one place to another place, A to B. But it has not happened in the computer systems, because here it is not just sending, it is manipulating. And manipulating, you want to change into, multiply it, reduce it, store it, move it in one direction, another direction. So that is Basically, if all those function we can do with photons efficiently, then it will be much faster computer, crazy computer.
What other industries do you think the material science has the most potential use case of? Currently, I mean, you have quantum computing, you have AI, you have aerospace engineering, and then you have like different types of like variables, right? So we talked about all of them, but is there anything specifically that material sciences is the most relevant to be used?
It's this motion, right? Transportation. So batteries are very important in motion. When I'm talking about moving from one place to another, it's all material science, right? Whether you can use hydrogen or not, right? Or you have batteries that are more efficient. Right now, batteries are really very low efficiency. They cannot be used. They have a lot of limitation. They cannot be used in very cold climate, the very hot climate, right? uh, and they are costly. Everyone is worried about lithium and other molybdenum, nickel, all those things that are being used in batteries. So that is not sustainable, right? Companies like CATL, they have made sodium batteries, very efficient sodium batteries, and they just launched it, and I don't, they have not released the details of it. But breakthrough in battery technology would be very crucial for our energy security. That you can take the sunlight or in nuclear energy or somewhere the energy, and then store it and use it wherever you want. Right? Batteries are everywhere. Your laptop, your phone, your car, everywhere. Right? So they will be crucial.
Do you think that we can make some sort of system wherein we can store a lot of amount of energy into just like small systems? It's almost like a small battery, like a very small battery, which people can put in their pocket and then use it, to uh, for like bigger applications even. Or that's not a possibility.
You mean longer, pretty long, instead of sort of it getting discharged.
Yeah, like I mean, if you think about it, like exactly. Yeah, that's what I was talking about. Like you have the lithium ion batteries, you have even the batteries that we use in the remotes that we operate, and all the different batteries. For example, cameras. Cameras take so much battery, and the biggest problem right now is that the battery drains off very fast, and that the heating affects it so much that you cannot record longer videos. So you have to have an external adapter. So can you come to a point wherein like these batteries can store more amount of energy and more amount of power and generate less heat?
Yeah. So see, if you watch the Apple keynote or Apple event, WWDC event, just 2 days ago, 3 days ago, you would see that the biggest thing that people worry about in iPhones is batteries. Biggest space that any part takes is batteries, actually. So they launched iPhone Air, 17 Air, and that has everything in that little bump, camera bump, all sort of parts, which run all the computing part are in that bump, and rest of the body is all battery. It is like it is like it's like human body, right? We have the brain here, and then rest of it is you can say battery.
Yeah, yeah,
So,
yeah.
you absolutely right that batteries are very important. There are certain batteries that provide very little power, and called nuclear batteries, that provide very little power, like very, very little power. So, and those can run forever.
Mm.
But so your question is more futuristic looking, whether something like that happen. I would say that need to happen. I mean, that certainly would happen because that's kind of necessity.
Mhm.
Many
And
forms of batteries would come, like a small form that can run very long but provide very little power. So there is a lot of designs that would come in. A large battery which can provide in certain time frame, it can provide power, but huge amount of power. So
And what material will go in these batteries?
different materials, depending upon application, different kind of materials. So, for example, if you look at a lot of, either hydrogen, people talk about a lot. Hydrogen is like a battery, right? Because it actually, you split the hydrogen, make the hydrogen, and hydrogen then combines back to make water, right? In that process, it gets energy, right? So it is kind of a battery which stores power. But hydrogen is really useful or for long haul application. You are running a ship that has hydrogen, or you are running a truck that has hydrogen. It goes 1,000 miles without stopping. So there, because stopping means, frequent stop means that you are losing money. So there, the gas does not make sense. Hydrogen makes sense. Okay. So what I mean by that is, depending upon the application, you would have a custom material or custom kind of battery or material or gas or liquid that would come into play.
Hmm. And do you believe in the hydrogen as a source for fueling cars, or that's not a possibility?
So, I mean, it is a possibility, but whether it is a fitting application, I would say it is not probably a very fitting application. The fitting
What is
application is
that?
long hours, because hydrogen requires very high pressure. Cars are like frequent a small amount of and they are happy with, like, 200 miles, 300 miles of refueling. So for them, hydrogen is costly. It's just very costly for companies. So that is not going to fly. But for trucking application, yes, it is. Presents a value proposition. It has a value.
So it's a very specific use case for trucking, U-Haul, like hauling type of businesses or trucks,
Yeah,
any big heavy load.
yeah. Everything. I mean, all sort of material have a specific application. If something you can get cheaper, why would you not? And higher quality, then why would you not get it, right? So same thing happens with different materials in different applications, right?
Yeah.
So so you have a certain application, you try 5 different materials, and one that actually provides you the best trade-off. That is what you're going to use. That is what
Yeah.
happening.
Yeah. So I know that you touched on the EVs, the electrical vehicles, and I own one electrical vehicle, and I love using it. Everything is the best. It doesn't make any sound. It's really good for the environment. I like driving it. It's very smooth. But one thing I don't like about it is that it only gives me 270 miles for one charge, for one full charge. I mean, that's like crazy to me. Like, we are living in 2025 and we have not figured out a way to kind of go up to like 500, 600 miles with our batteries here.
I mean, 10 years, 20, 15 years back, we did not have EV.
That's true. That's true.
So, right? So, given to that, I feel that it is fairly good progress. Uh, you know, could be, uh, we could have been better. Uh, yes, I think we could have been, but I will take this. It's okay. But certainly, I think China has, I mean, what I have seen and I'm hearing and seen myself, I think China has an edge on EV, and they have longer range vehicles, and I think that they would at least in next 5 years, 10 years time frame. I think there will be a couple of Chinese companies, EV companies, that would be world class. Nobody will be able to ignore them, and then couple of, I think, US companies that are legacy companies probably would be reduced in size, like really reduced in size.
Interesting. That's a really good prediction. And actually, I would agree with that because that, like you said, the company, I think it's called BYD, they have produced their flagship electrical vehicle, which is very inexpensive. At the same time, it's very long lasting in terms of the mileage, and it's like so lightweight as well.
Mhm.
So, if you think about it, like Earlier we used to be thinking that like the innovation is something that Chinese companies lack, and they are very good in manufacturing, but it's the opposite side now. I think we will be mimicking Chinese innovation when it comes to like long mileage electrical vehicles, and also making them cheap and light.
That's true. I think maybe certain areas I see that material research has surpassed the US, and in certain areas they did not. So, for example, very cutting edge semiconductor tech, I think the US has a lead, quite a big
Really.
lead. Although I don't know how long that lead would be, but I think it is pretty good lead. US has.
And what do you mean by semiconductor tech lead? Like, give me some examples of like why do you see that difference?
So you see the AI chips, right?
Yeah.
So the chips are being made in TSMC, which is Taiwan Semiconductor Manufacturing Company, but they are manufacturers. So they have the most cutting edge tech, fabrication tech. So they are designed by NVIDIA, but they are made by TSMC. Same thing with Apple, that their chips are made in TSMC, used to be made in TSMC. Now Samsung is going to make some of the chips Samsung is going to make. But the point is that where is Apple and where is NVIDIA? It is in 5 miles, 5 miles of where I'm located, right? Silicon Valley. So it's still the lead is there, but where is BYD? Where is Qatar?
So miles. Yeah.
Largest battery manufacturer. They are all in the. So you can see where the leading companies are, and you can kind of have a fair idea or who is leading what.
Yeah. That's such a good point. Yeah. And I know that you have to go, and unfortunately, our time is coming to end here. But I do wanted to ask you: you have done your degree in material science, you have done your PhD in photonics, and you have been in this industry, material science, for so long. We have seen so many different industries getting different applications of material science, and new materials being generated. Like, I wanted to ask you if somebody wants to join in the material science career path, or want to make more or want to gain more experience, what advice would you give them so that they can learn about it, get educated, and even apply some intersection of AI, semiconductors, and other related fields in material science?
So Elon Musk said that take materials 101 and you will not regret it. I think what has happened that in the AI, advent of AI would actually make a lot of, and you must have, so it's always the new technology comes and disruptor comes, and people think that it will just take away, it will not add anything. I feel that the ambition of human being is so high that it certainly makes a lot of field make them disappear, but it also adds a lot more than what it made to disappear, right? So it at the end, basically certain fields will go away completely, right? So for example, like typewriters, they are gone, right? Uh, there are certain things that are in decay. Theaters are in decay, right? It used to be a big thing, but now everyone watches it on their theater system, right? So what I'm saying is that technologies slowly take away certain things, or certain things they just take away completely, but they add so much because of the ambition of human being. If we make a technology which very easily take us to space, then we will start trying to go to another Milky Way or another solar system, right? So the ambition is unlimited, right? So if one thing become possible, then new things, just it is kind of a stepping stone to 1,000 new things. So that is how I see it. Now, to answer your question, certainly take material science or some sort of physical sciences. What AI has done is that it has made the coding and software related man-made things that were like sandbox made by the human being, like software coding, very easy. Writing a book, very easy. Creative tasks, very easy. What is left is that things like material science, where you are dealing with real world materials, right? Where things can go in very different direction because it's not a man-made thing. The discovery of material is still not figured out, and I don't think that AI would really help. But I think it's still there are millions of questions that are not answered. Very simple system we have mastered, right? Silicon. I was talking of silicon carbon, but we have not mastered even double, like two type of element system. There are so much to do there, that and there is a pull also, because the new material need to be discovered in order to support AI, right, or hardware. So I feel that this is the kind of time when material science kind of field become lot more important. What my uh, advice would be, is a long answer. My advice would be just do material science, but do at the intersection of other things. Learn coding and do with AI and material science. Kind of 2 or 3 field, because everything is interdisciplinary, cross-disciplinary right now.
That's such a great advice, and I really like how you described, everything that has to combine together, and you would need like new types of materials. We are very like we still have not discovered so many materials in the on Earth and outside